There we are. Okay. Hello, 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 everybody. How's everybody doing today? I hope everybody's doing good today. All right. Hi, everybody. Hello. Oh, hey, Yvonne. You want to post Tuesday's video? That's fine. I can post Tuesday's video. That's no problem. You can also watch it here on Twitch, Yvonne. So you don't have to wait if you want to watch it here on Twitch, Yvonne. If you want to, do that, that's totally up to you. But yeah, I that's basically it there. So you can go underneath videos. Oh yeah. No, nothing to be sorry about. Maybe I wasn't too clear about it, so I'm the one who should apologize. But if you go underneath the videos tab here on my channel, um, the Twitch will keep my videos here for up to 14 days after their initial broadcast. So you can click on videos there, and then you will see a replay of Tuesday's broadcast. So you can certainly watch that at any time, and it's posted right after my broadcast is done. So, but I use YouTube to pretty much archive everything. So because obviously Twitch will only keep my stream, will keep the replays, excuse me, up for the 14 days. So if you want to watch older videos because life happens or whatever, and you didn't get around to doing it for a week or two, then at least it's there for just that. But yeah, you can watch that right away here on my channel if you like. So no problem. No problem. No problem at all. All right, we're gonna start here in just a minute. We'll wait for just a few more people to come on in, and then we'll just get going here. So it shouldn't be too much of a problem. We'll see how things are going here. Oh. Start this. Have this. Yeah. Okay. All right, let's go ahead and get going here. Okay, let's do it. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, what we're going to be doing here is we're going to be doing another couple sections here in regards to percentages that we discussed about here last time. Now, if you recall here from what we did on Tuesday we discussed how to solve certain word problems with percentages. And we saw that there were two main methods of which to do so. Let's go ahead and talk about those two main methods here really quickly. All right. So the two main methods that we looked at here. All right. So method one was using percents as decimals and basically converting the word problem. Okay, so that was the first method. And method number two here that we talked about is right what you see here below here on this page, and that is to use proportions, okay, to find the missing value. Okay, so those are the two methods we talked about here. Again, either using proportions where we went ahead and cross-multiplied, solve for the remaining variable x, that missing part, or we can use percents as decimals and convert the word problem. Now, those are two of the main methods here, and that's what these two next sections are going to refer to, is we're going to go in depth a little bit more here on these next two sections, all right, in regards to in regards to how to solve for certain percentage problems, okay? So let's take a good look here at this first part. We talk about the part and the whole and the percent. We did talk about how to set up these problems here last time. So let's talk about what the key is behind these particular problems here. All we need to do here in these problems, if we're setting up a proportion here, so if we're doing it the proportion way using method number two, the key to setting up a proportion is to identify the part, whole, and percentage. And basically just need to identify the part, whole, and percent, and plug the numbers in, appropriately. Okay, so that's what essentially what we're doing here is just, hey, we're gonna circle the numbers here because the numbers gotta go somewhere, okay, when we read the problem. All right, so the number's gonna go somewhere, but the question really becomes is like, okay, if the numbers got to go somewhere, well, let's identify where exactly they go. Do they go in the part? Do they go in the part? Do they go in the whole? Do they go in the percent? What exactly are we looking at here? So let's take a good look here at several of these problems here. And I want to identify here where each part has to go. So let me go ahead and zoom out of this really quickly here because I want to still have that up above there. So I just want this, part here of part, whole, percent, and 100 here for this first problem. So we can identify which numbers go where and how we set this up using a proportion. So the first problem says find 15% of $160. Okay, so right away, there's one thing that we can identify right away, and then it says, okay, it says 15%. Well, we can easily identify here 15 as the percent part, okay, because it has percent right after it. So by far and away, that's the easiest one there. 15 is where percent should go in this setup that we had discussed here last time, and what we'll do here this time. Now, of course, that takes care of the 15 part. That part's done. Now, there's only one number left in this particular word problem here, and that's 160. Okay, so the real question is, we already have the percent part there. That's fine. 100 has to go there every time. All right, fine. So the question is 160 the part or the whole? Okay, so that's the question that we have to ask here. Does that represent the part or does that represent the whole? What do you guys think? If you read this problem here carefully, okay, what does $160 represent? Does that represent the part or does that represent the whole? Okay, that's correct. The answer is the whole. Right. So this represents like the entirety that would like say what you have in your pocket, for example. Okay, I have the entirety of $160. All right, that seems fair. All right, seems fair. So we now know where to put each respective number. So we have the part here, which we don't know. X is going to be our part because we don't know what the part is. That's kind of like our unknown quantity. Our whole here is 160. Our percent here is straight up 15. And we're going to have 100 just like so. Now we want to do the same thing that we did last time, okay? And we're just going to cross multiply here, and we're just going to see what we get. So on this left-hand side, we're going to get 160 times 15 equals 100 times x. Can anybody tell me 160 times 15? What's that going to be? What's 160 times 15? 2,400. Good. Hey, down by the river. How are you, buddy? Been a while. All right, so we get 2,400 equals 100x. And how do we solve for x again? What do we do? Close this up. Things are going very well, my friend. Positive vibes over here. How do we solve for x here? We have 2,400 equals 100x. What's that algebra thing that we have to do here once again? How should we solve for x here? Divide? Divide what? A lot of things, everybody can say divide, but you gotta tell me by what? Or what exactly are we doing? Divide 100? Okay, just divide 100 here. Both sides, good. All right, so that's the key there, that's right. So again, everything in algebra is a balance. So both sides we gotta divide by 100, that's absolutely correct. All right, and now we just find our value for x here. X is going to equal, what do we get here, 24. Okay, so you can divide 2,400 divide by 100, and we get 24. Good. Okay. All right. Now, let's have you guys give it a try. Okay. So we have a setup here from this previous problem. Let's have you guys try letter C. Okay, let's have you guys try letter C. Let's take a minute, all right, and have you guys try letter C, again, in the same vein that we did in the last problem, okay? So again, again, we want to be able to set this up properly here. I'm going to zoom out just a bit more so you have the full page there to help you out. Okay, so let's try letter C here. We'll take a minute, and once you have an answer there, go ahead and post that in the chat. May need to use your calculator a little bit for this one, so just be a little careful. All right, took about a minute here. Let's go ahead and take a look here. And let's see here. I didn't get an answer here, so hopefully you guys got this. I hope you guys will get the same answer that I do. So kind of important for this one here, because you guys kind of get to use this. 18,900. So 7% of 2,700 miles is more than 2,700 miles. That might be a little bit long, though I think you're awfully close. At least you're kind of halfway there. Let's take a look at that answer there, Yvonne. So 7% is our percentage here. So we're going to have on the right-hand side here 7 over 100. So that's the percent over 100. On the left side here, again, 2,700 is our whole portion here. So this will be our whole. And we're going to have, again, we don't know what our part is, so that'll be x and over 2,700. So we're going to cross multiply here. So we have 2,700 times 7 equals 100 times x. All right, now I'm going to agree with you, Yvonne. 2,700 times 7 is definitely 18,900. That part is definitely true. But we can't forget about the last part here. We need to divide by 100 here on both sides once again. Okay, so that's going to be the important part here. So that's why I was mentioning here, that's really, really close. The only reason why I say that's really, really close is because you have to do that last step right there. So x here is going to equal, if you actually divide that out, exactly, very nice, Yvonne, 189. So 189 miles here is the correct response. So I found that to be, is that 900? Oh, yes, this is 18,900 here, Hannah. If that was the one that you were looking at there. Yeah, 18,900. Apologies if it's not so clear, just yeah, just correct me on that. Sometimes my handwriting is under 7. Yeah, this is a 9. 18900. Of course, we can do another example. 18900, Hannah. Yeah, let's do another example. Let's go ahead and do yeah, let's let me try and speak. I'm trying to say the right thing, but didn't come out of my mouth. Let's try the next one here, letter D. Okay. Okay. Let's go over this again. Let's go over this together. All right. So we have 48% of 1,580 kilowatts. Okay. So let's set this up together. Okay. And let's see what we get. All right. So what should we have on the right-hand side here? The right-hand side here, we should have a percent over 100. So one thing that's set in stone is this 100 is always the same way. It's always going to be right there, okay? What should go over 100 here? Let's at least define that right away. 48, that's right, because that's the percentage that we're given here in the problem, okay? So we're given 48%, we're going to put that percentage over 100, okay? And that's what we're going to want to do. Now, the question is, once again, let's take a look at 1580. Is 1580 the part, or is it the whole? Is 1580 the part, or is it the whole? Is 1580 the part, or is it the whole? We got the part, remember, we have the part over the whole equals the percent over 100, okay? So 1580 here is going to be the whole, all right? So we're going to put 1580 on the bottom here, and we're going to put X up top here to be our part. Let me go ahead and rewrite this again because it looks pretty messy from there. So just going to rewrite this one more time to make it a little more clear. And I'll zoom in on it so it'll be easier to read. Let me make this a bit bigger here. There we go. That should be a lot easier to see. Okay. Okay, so this is the setup of our problem right here. Okay. So now we're going to go ahead. Okay, actually, you guys tell me, what should I do next? What should I do next? Cross multiply. Okay, good. So that's the big crux of the problem here, is we're going to go ahead and cross multiply here in this instance. So on the left-hand side, we're going to have 48 times 1580 equals 100 times x. Okay, now again, you could use a calculator here for 48 times 1580 because we want to solve these problems here quick. So 48 times 1,580. And what do we get here for that? All right, 75,840. Okay, as I mentioned here, calculator's okay. Again, we want to be able to do these problems quicker, so that's fine. All right, and what should we do next then? All right, let's divide. Divide by what again, Yvonne? I'm going to keep asking that. All right, yeah, I'm going to keep asking that because that's going to be a thing. Definitely one of the things in algebra that we cover. Okay. And so what do we get here? We take 75,840 and we divide by 100. What's our final answer? Always, balance is the key word. Absolutely, 100%. It's the best way you understand algebra. 458, 458.4? Oh, I think you meant 758.4. Well, that's exactly what we're doing here. We're going over ratios here, Hannah. This is basically a proportion or ratio. So we've set up this specific proportion or ratio here based on, of course, the percentage being one side of that proportion or ratio, and then the part and the whole here being the other side in that case. We're definitely going to do a lot more examples, though, I can assure you of that, with more of these proportions. Yeah, 758.4 here. That's fine. Yeah, this is mistype. We can go over some problems here after class as well, Hannah, over ratios if you want to know. So there we go. Alrighty. Okay. Let's see here. All right. Just want to check a couple things here. Okay. Let's take a good look here at a couple of other problems. These next few problems are pretty much one and the same. Nothing too much going on there. Pretty much setting those up using ratios. I do want to do one of them in particular, though, really quickly. So the one I want to do here specifically is going to be, let's do that one. Let's do letter C. Yeah, absolutely. I'll be happy to do that for you. All right. All right. All right. Okay, so let's do letter C here. And I want to give about a minute here to give it a try here. Again, it says find 140% of 60 miles. Now, I'm going to let you know here, there's one thing I do want to make a note in relation to this problem here specifically. All right, so we'll make a note here. Note, if the percentage is above 100%, then the answer is higher than the initial amount. Okay, so this is always going to be true. All right, it's always going to be true. You're going to always have the higher than the initial amount when you have something above 100%. Okay. So what that means is that since we start off at 60 miles here, your final answer here is gonna be above 60 miles. Well, I don't know exactly how much, but at this point, but I know it's gonna be more than 60 at the end of the day. All right, so that'll get you in the correct mindset. Is if you get an answer that's bigger than 60, then you're definitely on that right track. Okay, so let's take a minute here. I want you to give it a try here. Again, we want to set it up the same way we did the last couple of problems. All right, with our proportions in mind. All right, and let's give it a go. Okay. Once you have an answer there, go ahead and post that in the chat. Okay, you got 84. 84, good. All right. Okay, let's take a look here. And let's see if we indeed got 84 as our answer. Okay, so first and foremost here, 60 is going to be our, now actually, let's start off with the right-hand side first, because that's what I did before. 140 is going to go up top here, and we're going to put 100 here on the bottom. Okay, so 140% over 100. On the right-hand side, 60 here is going to be our whole part here, just like we talked about from before. So 60 is going to go here on the bottom. And then x here is going to go on the top. Now, if you cross multiply here, we're going to have 60 times 140 equals 100x. 60 times 140 is 8,400, which equals 100x. Let's divide by 100 on both sides. And so x here is equal to 84. All right, so 84 is indeed the correct answer to this problem. Great, nice job, everybody. All right. Any questions about those type of problems? No? Okay. All right. Let's go ahead and move forward then. All right. Let's look at some application problems here. As in this section here, there's a few application problems, and we'll see how to put these kind of two things together here. All right, and we'll see how we do that. All right, let's look at this first one here. Raley's Markets has 850 employees. Of these employees, 28% are students. How many of the employees are students? Okay, so that's our question here. Now we could go through, it says 6 problem solving steps. In reality, problems like this, for example, since we've been talking about, proportions here and setting it up here, key is once again the same key that we talked about right here at the beginning, is to identify, is basically straight up to identify the steps here. So identify, well, not the steps, identify the percentage, part and whole, dependent on what's given. All right, so we don't know exactly what information we're given here, but what we do know is that we just are going to identify the percentage, part, and whole here, and then set up the problem. I guess I should probably add that. Let me add that. Oh. Okay, so let's take a good look here at this one. Let's just identify here. Right away, we have a percentage. We're given 28%. So again, we know that 28 over 100 has to go over here to the right. Okay. And so this marketplace has 850 employees. Okay, so once again here we answer the question. Is that going to be the part or is that going to be the whole? Okay, very good. That's correct, Yvonne. So 850 here is going to be the whole once again. Exactly. So that's what we have here in this case. And then we just rinse and repeat the same process that we just talked about here. So, oh, whoops, wrong way. Put that on the right side, not the left side. No. So here we get, not that way. Right, so we get 28 times 850 equals 100x. 28 times 850, what's that going to be? All right, 23,800. Man, that's, come on, 23,000, not 28. Then we'll do the same thing here. We'll divide it by 100 on both sides. Okay, and so here we get our final answer of like 238. Okay, so after we divide by 100 there, that's what we get for our final result. And there we go. Bing, bang, boom. Got it. All right, nice. All right, any questions about that? Again, same technique as we did in the previous few problems here. Again, there's not much difference going on here in this problem. Again, just putting those pieces in the right places, and then we're able to get our final answer just based off of that. Okay? So not too bad. Okay. All right. Now, let's take a look at some other problems here, because these next two are basically the same type of problem here, but I don't want to keep repeating these types of problems here. Now, let's take a look here at these examples. Now, this is where we have to be very careful, and this is why I mentioned the key here from before is to identify the percentage and to identify the part and to identify the whole here. So let's read this problem here carefully. It says 8 smartphones is 4% of what number of smartphones? So 8 smartphones is 4% of what number of smartphones? Okay, so right away, if we're setting up a proportion here, one thing we can take to the bank here is the 4%. I think everybody can agree. That's pretty easy. You put 4 over 100 here on the right-hand side. That part isn't too hard. But let's identify the left-hand side, because that's where the key portion of this problem is going to go. Let's look at 8. What is 8 here in this? What is 8 here in this particular problem here? Does 8 represent the part, or does it represent the whole? Does 8 represent the part, or does 8 represent the whole? That's correct. Okay, both Hannah and Yvonne, both of you are correct. 8 actually represents the part here. Now let's talk about why, okay? Because we need to make it clear about exactly why is this the case. Let me show you what the difference is between the previous problem and this problem, okay? Okay, and I'm going to go all the way back up here for just a second, and it'll make a whole lot more sense. In this case here, like what we did for letter C, it says find 140% of 60 miles. Now, the key word here for us to identify this as a whole is actually the word of. Of, if you recall here back in math language, of represents multiplication. So if we take 140% times the whole, then that means we get, the remaining part there. Okay, so in this case, everything's kind of flipped on its head. It says, okay, 4% of what number? So 4% of the whole i.e. what number. Again, a way we can say is 4% of what number, 4% of, again, which means multiply, of the whole is equal to, is means equals, and equals to the part. So we see here how things are going to go in this particular instance. The part here is equal to the percentage, whatever that percentage is, we don't know, but that's just some random percentage they give us in every problem, of, which means to multiply, again, of the whole. So this is the way we're going to see it here in problems like these. The part here, okay, somehow the part here is equal to the percent, whatever percent we're given, and then we multiply that by the whole. So that's why 8 here is going to be very important. And again, I'll just translate this. Remember, if you see the word is, you know that means equals. If you see the word times, okay, that means the word of. Again, I know they're mundane words, but in math language, they actually has a very big significance. So here in this case, 8 is going to go on top because that's where the part goes. And then that means that x here is going to go on the bottom because that's going to represent our whole part there. We repeat this process here once again, by the way, so nothing's going to change in terms of the actual calculation, but really it's about the setup here at the end of the day. So we're going to have 4x here is equal to 8 times 100. Let me go ahead and put it over here. So we get 4x equals 8 times 100 is pretty easy, 800, straight up. We're now going to divide by 4 on both sides. And if we get our final answer here, x is going to equal 200 straight up. There it is. Okay. Are there any questions about that before we try another example? No? Okay. Okay. Let's try the next example here. Okay. So the next example that I would like to do here is, which one do I think would be good for you guys? Ah, yes, this is a good one. Let's look at number 3 down here. Okay. 387 customers is 36% of what number of customers? Okay, so let me go ahead and zoom out here once again. So we're going to do number 3 there. All right. So you have this previous example you can kind of work off of. So let's take a minute here. All right. And let's take a minute, give this example a try. All right. And then once you have the answer, post it in the chat. I'll wait for a minute here. It's fine. Take your time. We got 1075. 1075, all right. That's one answer there. All right, looks pretty good. All right, 1075 there, good. All right. Okay. let's take a good look here. Let's find out. All right, so here, let's go ahead and take a look here. We have our percentage, which is pretty easy. Again, we have 36 here on the right-hand side over 100. So that, again, that part's not changing. Again, though, our key here is, of course, goes down to 387. Now, 387 here in this case is going to be our part as opposed to our whole. So we're going to have 387 divided by x. Okay. I'm going to go ahead and cross multiply here. Go ahead and zoom in here, make this a bit easier to see. All right. So on the left-hand side, we have 36x equals 387 times 100. Okay. So we get 36x equals 38,700. Okay. We'll divide by 36 on both sides. And then if we do that out appropriately here, we indeed are going to get 1,075. So that is going to be our answer for x in this case. Good. 1,075 is the correct answer. Nice. Okay. All right. Great job. All right. So far, so bueno. All right. Now they do pretty much do the same thing here in these word problems. These word problems are pretty much the same type of word problems as we just did up above. But we can take a look at some of the language here that they use in some of these word problems here. So let's just take a look at this example and we'll see what they're talking about. Let's look at this first one. At Newark Salt Works, 78 employees are absent because of an illness. If this is 5% of the total number of employees, how many employees does the company have? Okay, so the key word here actually in this case is the word if this. What are they talking about if this? If this refers to the 78 employees that are absent because of illness. So if I just cross out if this with 78, 78 is 5% of the total number of employees. You can see right away it's pretty much the exact same question that we had from before, just with, of course, different numbers. So all we have to do is set it up the same way we did the last problem again, and just go ahead and proceed to go from there. So again, we have 78 over x, cross multiply here, get 5x equals 78 times 100. So we get 5x here equals 7,800. We'll divide by 5 here. And what do I get here off the top of my head? 1 and 5. 1560. I think I get 1560 off of this. So, is that right? 1560? Did I get that right? Maybe I did. I just did off the top of my head. So, let me see. Oh, I did. Okay, good. All right, so 1,560 employees is what they have here. All right, so as you can see here, again, nothing really changes in terms of this, longish word problem and what we just did with the shorter-ish kind of word problem. Same setup, same everything, nothing changes. Okay. Okay, finally, the last part here is basically finding the percentage part. So in this case, let's look at this here. It says, okay, let's look at letter A here. 13 coupons is what percent of 52 coupons? All right. So again, we just want to identify our part, our whole, and our percentage. The only thing is that in this case, we're trying to figure out what percent. So in what percent, we just call that, once again, we just call that X. Now let's identify 13 and 52 here, respectively. Okay, so we're going to focus on those two guys. So on the right side, we're going to have X over 100. That part is going to be true because we have what percent. What about 13? Is 13 going to be the part, or is it going to be the whole? Is 13 the part, or is 13 the whole? Okay, really, very good. That's correct. All right. So that would mean that 52 is the whole here by default. I'm going to put 52 down here. And we're going to go ahead and put 13 up here. Okay. Pick that up. Okay, good. There you go. Nice, nice, nice. Just have to make sure that that didn't. Okay, that's fine. All right. Just making sure of something. All right. Okay, so all we're going to do here is. Oh, it doesn't look very. I just looked at this. I'm like, that doesn't even look like 13. That looks like doesn't look like anything. All right, so let's look at 13 here. There we go. So let's go ahead and cross multiply here, and we're just going to go ahead and straight up find out. All right, so we have 52x equals 13 times 100. So 52x, my bad. So here we got 52x equals 1300. We'll divide by 52. And so what do we get for x here? What's x equal to if once we divide by 5200? So 1300 divided by 52 is 52? Oh, 25. Oh, okay, it was the other way around. All right, so 25. Good. All right. I was like, 52. Like, oh. Like, we get the same number again. All right, so 25% is going to be our final answer for that. All right. Let's go ahead and have you guys try one more here. So go ahead and give number 3 here a try. Okay, so we'll take a minute for that. And then we're going to move on to the next section here. So the word problems are pretty much the same. So what percent of 2,280 court trials is 1,026 trials? 45? Okay, good for time. All right, 45, you say? Let's go ahead and find out if it is 45. Hopefully, got 45 here. I actually don't know, but we're going to find out here together. So x over 100, we don't know what percent yet, because again, we're given what percent. 1026 is going to be our part. 2280 is going to be our whole. So our part here is going to be, again, our whole and part here, 1026. Divided by, again, 2280. Cross multiply. So we're going to have 2280x equals 1026 times 100. So we have 2280x equals 102,600. And then we're just going to divide by 2280 on both sides. All right, so this one here again would be a calculator-based problem here. All right, and indeed we can get 45. All right. All right. And that's our final answer, 45%. Spot on. Really nice. All right. Any questions? Nope. Okay. All right. Okay. This year, rainfall this year. Okay, that's right. All right. Actually, one of these problems is actually rather important. Actually, I will do one more here from this section. After all, I'm going to do this one here. All right. Let's do this one here and let's see what we get for this one. Rainfall this year was 33 inches, while normal rainfall is only 30 inches. What percent of normal rainfall is this year's rainfall? Okay. Now, of course, we have to find what percentage in this case. Okay. So again, on the right-hand side here, we're going to have x over 100. And that part is true. Now, I want you to look carefully here. Let's look at 33 and 30 here. Okay. So what would 33 be here in this case? Would 33 be the part, or would it be the whole? 33 here would indeed be the part. That is correct. Let's go ahead and talk about why. If we read this problem here carefully, it says what percentage of normal rainfall is this year's rainfall? So again, as we know here, we say, all right, again, we say part, again, part here is going to equal, again, the percent times the whole. So again here, remember that equals means is. So this is where is at, all right? So if you want to look at this year's rainfall here is going to represent the part here in this case. And that means that normal rainfall here is going to represent the whole. All right, so we're actually looking at it from purely an interpretive point of view. So again, that's how I'm going to go ahead and figure out. So it's not always going to be, let me put a note there, okay? Let me put a note here, and I think this is definitely one of those that's important. Okay. Read the problem carefully. Read the problem carefully to determine part and whole. Note 2. It is not true that the smaller number is the part and the bigger number is the whole. All right. So you can't fall underneath that idea where it's like, okay, bigger number whole, smaller number part. Okay, that is not true. You have to actually look at the problem, read it carefully, and then make a determination whether or not you have, again, whether or not that's a part or a whole. Remember, we can get things above 100%. So because we can get answers of above 100%, well, that's still relevance of this second note. It comes into play. All right. So in this case here, what we set this up as is we set this up as 33 over 30. And so here we get, again, 30x equals 33 times 100. 30x equals 3,300. Divide by 30. And so finally we get a final answer here of x is equal to 110. So 110% here would be your final answer for this problem. All right. Any questions about that? Actually, let me move this up here. Sorry. Some people forgot. I went too fast in that regard. So people want to take a look at the notes, and that's important. All right. Okay. Actually, maybe, yeah, we're getting running out of time here a bit. So thought I'd get through 2 sections here today, but I think I want to give you some. Okay, let's have you practice some problems nonetheless. We're effectively doing 6.4 anyway, so, or the next section anyway, 6.5. So, I guess more practice here isn't going to hurt. All right. I want you to go ahead and give number 1 and number 2 here a try. Okay, so we're going to spend like 2-3 minutes here. I want you to give these 2 problems here a try, and then post your answers in the chat for both 1 and 2. Okay. I'll give you like we'll take like 3 to 5 minutes. We'll do that. Oh, All right. Like I said, once you're ready, go ahead and post those answers in the chat there. Cool, cool, cool. I guess 68 and 65. All right. Anybody else have some answers for me? Okay. Weird. Uh, kind of weird. All right. Anyway. Okay. Let's take a good look here at let's take a good look here at this this guy right here. All right. So the bid price on an auction item is $289, while the minimum acceptable price is $425. Bid price is what percent of the minimum? All right. So we have our part here of $289, our whole here of $425. That's going to equal x over 100. We'll cross multiply here. We'll have 425x equals 289 times 100. We get 425x equals 28,900. We'll divide by 425 on both sides. Oh, that would be 425 here. There we go. All right, and we're going to get our final answer here. Again, you can bip bop boop that in the calculator there. It would be helpful if I put in the right number. Okay. The answer is indeed 68. That's correct. All right. I'm going to do one more after this. So just have one more for you guys to try. But really quick here, this is going to be setting this up here, be 52 over 80 equals x over 100. Again, you'll cross multiply here once again. You'll get 80x equals 52 times 100. So 80x equals 5200. We divide by 80. And so we get 5200 divided by 80. So indeed we get 65. So good. 68 and 65 is the correct answer. All right. Now the last one I'd like you to try here is number 4. So let's take a minute or two on that one. Let's take a minute or two on that one, and then find out what we get for that. So the service department set a goal of 360 service calls this week. If they made 432 service calls, find the percentage of their goal that they reached. Okay, so that'll be this final example here for today. All right. Anybody got an answer for me here? Okay. If not, that's okay. 120%? Okay. 120? All right. Okay. Let's go ahead and find out if we get 120. I kind of like that, though. I think it sounds pretty good to me. Let's find out, though. All right. First and foremost here, they set a goal of 360 service calls, but they got more than what they bargained for. They got made 432 service calls instead. Now, what this means is that 360 is going to be our whole, whereas 432 here is going to be our part. So definitely correct in that regard. We're trying to find the percent of the goal that they reached. So since it says their goal was 360. So this is going to be, again, another good indicator that that's going to be our whole part here. Their goal here, again, 360. So their whole part here. So we're going to have 360 here. And they made many, many more calls than 360. 432 equals X, because we're trying to find the percent over 100. Let's find out what we get. So cross multiplying, we get 360X equals 432 times 100. So we're going to take 360X equals 43,200. We'll divide by 360. All right, and then we just simply divide here in this instance. And what do we get here? We indeed get 120% is indeed the correct answer. Very nice, Anna, Yvonne. Very, very good job. Awesome. Okay, and that is the last example I want to do today. For that, nice work. All right, any questions about anything today? Next time, by the way, we're going to go over section 6.5 and 6.6, which will be the end of chapter 6. Okay, so 6.5 and 6.6 here are going to be the end of chapter 6, and then there'll be a test on chapter 6 here. And then from chapter 6, we're going to move into chapter 9. All right, so we'll be discussing about a test here about chapter 6 once we're done with chapter 6 here next week. And then we'll discuss about chapter 9 right after that, right after we come back from Thanksgiving break. So that's the plan here to get that done. All right. Okay. All right, so I'm going to leave my stream on here for right now because Hannah did have a question here that she wanted me to ask regarding ratios. So I'm going to leave this on here, but if you're on my first class here, then again, I wish you, thank you for coming out to the stream here once again. I wish you all a very safe, happy, and healthy, and stay sane sort of weekend. And I will see you all on Tuesday. Okay, we will see you on Tuesday. All right, so if you have to cut out and go, have yourself a wonderful morning/afternoon. All right, and we will see you next week. All right, so for those of you, please take care of yourselves and have a great one. All right. There is school next week. There's school on Tuesday, just not Thursday. So class on Tuesday, yes. So you're wishing that there was no school next week, but no. Classes on Tuesday only next week. Thanksgiving break is a thing, but it only applies to a portion of the week, not the whole week. That's correct, Hannah. So Wednesday, Thursday, Friday classes will not be held, but Monday, Tuesday will be held. That's how it will always go for you. What you can do is you can check for more details, not just for next week, but for future holidays. Check the academic calendar on the ECC website. So you could just do a search there for academic calendar, and you could find out any of the school holidays that were off. And sometimes it can be a little weird, so. Yeah, the academic calendar is set up like a year in advance, so you'll definitely be able to plan ahead around any time where the school is going to be closed, unless otherwise posted, of course. All right, Hannah. Question here. Do you what was your question from my math lab there? Your specific question. So I'm gonna go to my math lab here, and I'm gonna find the question that you had reference to. Okay. Okay. Do you have a specific question from 5-1? Yeah, there we go. All right. Then to get back to here to the beginning, and then it's gonna back to the thing. All right. It says to write the ratio as a fraction in lowest terms. Compare 3 feet to 245 inches. Okay. Oh, that's fine. Let's go ahead and take a look at a problem with that. That's cool. No problem. Let's take a look here. I'll just be able to find it quicker. That's why I'm just asking. Seven? Okay, let me go to 7. Okay. Oh, okay. I got you. I got you. All right, all right. So we have to compare. Okay, so there's two parts here to this particular problem. Let me go ahead and expand on this just a little bit. It's not as bad as it may seem, but there is one little there's one little detail here that you have to be careful about. And that is exactly this part here. It says compare in inches. So basically what we need to do is we need to put it in the same, for the same units here. So we have 3 feet to 34 inches. Now, if we were to put that properly into 3 feet to 34 inches, then let's put out our paint tool here for just a second. So 3 feet here, again, we have to convert that to inches first. So 3 feet, converting that into inches, remember that 1 foot is equal to 12 inches. Okay. So we're going to take 3 feet, we're going to multiply that by 12. Undo that. So here, in fact, we're going to get 36 inches to represent 3 feet. So we're going to now rewrite the problem here. So as the ratio, it says 3 feet to 34 inches. Now I know you're thinking, oh, it's 3 over 34, but that's not true because they're different units. What you should write here instead is you should write 36 inches because that's the same thing as 3 feet, and keep the 34 inches the same. They want us to compare it in inches. Now this right here, this 36 over 34 is what you reduce down. Okay, so if we start with 36 over 34, let's say I divide it by 2 because they're even numbers. You know, I'm just picking simple numbers. They're both even, so I can divide by 2. And if I do that, 36 divided by 2, I can figure that out. It's going to be 18. And 34 divided by 2 is 17. And then I can continue reducing down if I want, if I can, I should say. But I can't because 18 and 17 have nothing in common, at least in this problem anyway. So my final answer here is going to be 18 over 17 as a reduced fraction. Okay, so we're going to go ahead and put that in for our ratio here. So the ratio here is there a key to know how to compare them? So what it'll ask you here is it'll ask you to compare it in inches. Remember, the first number there is your numerator, and the second number here is your denominator. So if you want to know a key here that can certainly take it, is again, one of the keys here is to, again, read the problem carefully and make, I know that's kind of, and make sure you put both the top and the bottom in their respective units. So their respective units being they could be the same, they could be different, whatever the case may be. In this case, they ask us to put it in they ask us to specifically put it in inches. So it's like, well, okay, everything needs to be in inches, so we got to run with that whether we like it or not. Yeah. I hate these text boxes. Yeah, so that's a conversion you're going to have to kind of get to know. Is 1 foot is equal to 12 inches. Mercy. Thing is like awful. All right. Anyway. So if you're not sure how many inches are in a foot, you can always Google that. There are conversion charts everywhere for that. So just to let you know. Yeah, so take a look at what I did here first. So don't make this too hard, okay? So basically, I converted 3 feet into inches first. So 3 feet suddenly becomes 36 inches because then I use the conversion of 1 foot equals to 12 inches. So I have 36 inches over 34 inches, and then I reduced it after I changed the units on both the numerator and denominator. So I changed it to the same units on the numerator and denominator and then reduced. And that's because of what it asks us to do here. It asks us to put it into inches for both units. So basically, whatever the problem's asking you to compare, put it into those units. Did I have a Math 112 stream on Tuesday night? Yes, I did. Sarah, you can find it right here on Twitch. Just go to my channel page and go to videos. The replays here are basically here for 14 days after their initial broadcast, so you can reference that right away, Sarah. And you know that you don't have to wait for me to post it to YouTube per se. Twitch will keep it here for 14 days, and then you can watch it right here on Twitch. So if you missed my last live stream, that's fine. You can go ahead and go to my videos and then you can go ahead and watch it right away. So shouldn't be a problem. Can we do one more? Sure. Have to be really quick about it though. Okay. Now in this case here, they ask us to write the ratio as a fraction in lowest terms. So we have 39 and 3. Okay. Now in this case here, if we wanted to, there's a few ways to actually do this. Now they didn't ask us to put it into yes, 5-1 is 5-1 is on yeah, that was over 2 weeks ago. So 5-1 would be on YouTube. So you'll have to check the YouTube page, my YouTube channel for that. So, because after 2 weeks, Twitch removes my replay video. So that's why I archive it over to YouTube. So check out YouTube there if for 5-1 for the lesson there. Let me go ahead and put that in. Yes. There you are. There is my YouTube channel. Super handy. So in this case here, I think the ratio, let me check if the ratio, this is the case here. Okay. Let's see if this is the case here. Okay, so that's what they want here. All right, I just wanted to check one thing here. Sometimes it's a little unclear. All right. So what they want us to do is they want to compare 39 minutes to 3 hours. Under Math 90, but I remember changing it to 112 on Tuesday. That's kind of weird. Why did that happen? Now I have to look back myself. I'll change that over if that's the case, Sarah. I do apologize if that was the case. I'll need to check that out. So in this case here, let's go ahead and do this one here together real quick. In this case here, we're going to convert minutes and minutes so we can compare them. So, okay. So let's talk about one of the other keys here real quick. Okay. All right, so make sure to use the same units here if not specified. So in this case, We're going to have 39 minutes and 3 hours. So one thing we do know is 1 hour is equal to 60 minutes. So we're going to convert from hours into minutes here. So 3 hours equal times 60 equals 180 minutes. So we're going to have 39 minutes over 180 minutes. And then we'll go ahead and reduce that down appropriately. Let's divide by 3 here, at least to start with, if we can. So 39 divided by 3 is 13. 180 divided by 3 is 60. And 13 doesn't go into 60, so this is as far as we go. So 13 over 60 is going to be our answer here for our ratio. Sorry, I'm doing this a little fast here, Hannah. Apologies. All right, and that indeed is our final answer for that. So, so there we go. That's what we have here for that part. Check my video producer's part here. Could have sworn I put. No? Wow. Okay. Oh, okay. Weird. Well, I'm definitely changing that. Okay. All right. Some reason that was not there. And now it's there. Okay. Strange, strange, strange. All right. Okay, there we go. Perfect. All right. Change that over and edit that. Good. All right. Very good. Go back to my modding stuff here. Oh my gosh. Can I please? There. They're now blocked. Ban them. Oh yeah, I can ban them. There. Now I banned him. Good. I wanted to ban him, and I'm like, yeah, I gotta ban you. All right. Yeah, you got like 3 tries for the test there, Hannah. All right. All right. Okay, guys, been waiting here very patiently. Really appreciate it. All right, we're gonna get started here fairly soon. All right. All right, we'll start here in a couple of minutes. All right. There we go. I'll say hello to my 11 o'clock class there. Okay. Hello, 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 everybody. How's everybody doing today? All right. Who's here right now? Okay. Not sure where everybody is right now. No, you guys usually come out. It's kind of weird. Mm-hmm. Why would I do that? Oh, there we go. All right. There we go. Got it. Hello, everyone. How is everyone today? Fact of the day. There you go. I like your facts of the day, man. Oh man, that would have sucked. If I was like an early human, I'd be like, yeah, everything's kind of bigger than me. I need to run away. How are you today, Daniel? Pretty swag. I appreciate that. I'm doing pretty good, my dude. Doing pretty good. You ready to get started? I hope other people will join us here. I'm not sure where everybody else is, but hopefully there'll be other people to join us here soon. But it's just right now it's few people, so all right, let's get to it. All right. Okay, let's go ahead and get started. Let's go. I can't say anything today. Good morning, Carissa. There we go. We got a few more people coming in. There you go. Maybe just getting a little late going here. All right. Okay, let's get started today. Right, 18 years. Truth, truth. Okay, let's get started today. Welcome back. Welcome back to Thursday, end of the week time today. So today we're going to be continuing moving forward here in talking about percentages. We're going to be using it here in more application problems here. Now, let's talk about what we discussed here before from last time. All right, so last time here, we talked about two methods about how to solve particular percentage problems. Good morning, Robert. I hope you're doing well. How are you? Um, So let's talk about both methods here in this case. Method number one here in determining, solving the percentage problems is, we changed the percentage to a decimal and solved for the missing part. I'm doing very well, my dude. Doing very well. It's positive vibes week, man. Positive vibes. So, you can never go wrong with positive vibes, bro. All right. And then, so we changed the percentage to a decimal and solve for the missing part. Okay. Then, just by interpreting the word problem here. And method number two here was to, it's what you see right here on the screen, is to set up a proportion uh, to solve for the missing part or missing quantity, whatever you want to call it here. So we set up a proportion here to solve for the missing part. That was the second method. The first method, you could change it to a decimal. Now what we're going to be looking at here in the next two sections is we're going to be looking at both methods here in a little bit more greater detail. All right, so we're going to go a little bit more in depth about using proportions here. We did use it last time in the last section, and now we're going to go all in here and look at a few more of those type of problems in slightly different scenarios. All right. So obviously what we're going to need to have is we're going to need to have this guy here, part divided by a whole is equal to the percentage over 100. All right. So we're definitely going to be using that here. All right. In this particular case. Now, what we want to focus on here today, and let's talk about what the key is here today. The key here for today is to know, basically to determine what is the percent, part, and whole, and plug them plug them into their respective spots and solve. Okay, so yeah, sure. Is my my face is in the way, sorry. I gotta stop using my face as a way to block you from not reading anything, Carissa. I'm sorry. Okay. All right, there we go. All right. That's how it works. um, so that's the two methods here that we've talked about so far. All right. So we change the percentage to a decimal, solve for the missing part here. Set up a proportion to solve for the missing part. All right, very good. All right. So to determine what the percentage and part and whole are going to be, and plug them into their respective spots and solve. All right. So we're going to go over each one of these parts here carefully so we know how to set up these problems here appropriately in this case. So now, let's take a look at this first problem here. It says, find 15% of 160. So it says, find 15% of 160. So, in this case here, the easiest part that we're going to identify, of course, is 15. It's 15%. So 15 is going to go where the percent's going to go, right here to the right. Let's see. Go ahead and this 100 here, don't forget, is static, so that's not going to change. Let me zoom out here for just a second, though. So as you can see here, again, we put that percent over 100. So just note here that 100 isn't going to change in terms of where it needs to go. Okay. Now, the real question comes down to this. The real question comes down to, what is 160? Is 160, according to our setup here, if we're using a proportion, is 160 going to be our part, or is it going to be our whole? Is that 160 going to be the part, or is it going to be the whole? What do you think? It's going to be the whole. Okay, that's correct. So this part here, 160, right? We're taking 15% of 160. So if I had 160 bucks in my pocket and I want to find out what 15% of that is, well then, the whole part here, this is how much money in my pocket, is $160. So this 160, according to where it needs to go, is the whole needs to go down here in this part over whole. And the thing that we don't know here is X. Okay. Okay. Now let's talk about what we need to do next. Whoops. That wasn't the... There we go. That's better. Okay. So let's answer this question here. This is what we talked about on Tuesday. Okay. How do we go ahead and find? How do we go ahead and solve for x here? What did we do when we set up a proportion here in order to solve for x? You guys remember? What did we do here to solve for x? Okay. And we did that here. That's correct. And we did that here by cross multiplying. So remember, that is correct. So we have, again, we're going to cross multiply here in order to get that equation that Daniel's put down there. So what we have here, again, we have 160 times 15 equals 100 times x. So that's correct. All right, and what is 160 times 15? What's that going to be? 2400. Okay. That's going to equal 100x. All right. And what do we do next? What do we do next here? How do we solve for x? Divide both sides by 100. That is correct. So remember, this is the part where we get into the algebra part, but as we talked about algebra from last time, when we discussed about algebra from last time, we said, okay, the key to all algebra is balance. So if we're balancing stuff out here and we want to solve for x, we're going to divide by 100 here on both sides. And then we're going to get a value here for x. So x here is going to equal 24. Okay? Easy peasy, lemon squeezy. All right. Any questions about that so far? All right. None? Okay. If you guys got questions, feel free to interrupt me, all right? So the next part here is pretty much a kind of a participation part here. So what I would like you to do next, guys, is I would like you to, let's take a minute or two, just a small amount of time here. Let's go ahead and do letter C. Okay, let's do letter C, set up the proportion here, okay? Letter C says take 7% of 2,700 miles. I'll go ahead and zoom this out here for just a bit so you can see the last problem there. So 7% of 2,700 miles. And once you have an answer there, go ahead and put that in the chat. So again, it's okay to use a calculator for this, so you can go ahead and use that if you like. Got 189 miles. Okay. Anybody else? All right. Okay. All right. Well, let's go ahead and take a look here and see if it is indeed 189. So here we got 7%. Now 7% here, pretty easy. That should go on the right-hand side here. 7 over 100. Again here, this 2,700 miles here is going to be the whole. Okay, so this is the entirety of, let's say, how much we drove, okay, in a month or whatever. All right, so we're going to put 2,700 here. And we'll go ahead and put X here on the top. And so this is going to equal 7 times 2,700. So we have 7 times 2,700 here. Again, if we do that out, that is indeed 18,900. And you divide by 100 here. And so here, indeed, we're going to get here as X is going to equal 189. Okay, and that's going to be our final answer for that problem. So 189 miles, spot on, totally agree. All right, nice work, nice work. Okay, good. Okay, all right. Now, there is one more problem I would like you to try here. All right, so now that you have a pretty comfortable idea here, let's have you try one more problem here. And I do need to make a note about this before we start. That's here letter C. It says to find 140% of 60 miles. Now in this case here, I do want to make an important note so that way the expectation for your final answer will hopefully be more realistic. So if the percentage is above 100, so 100%, then your final answer will be will be bigger than your initial amount. So in this case here, for example, if I'm given if I have 140% of 60 miles, my final answer should be more than 60 miles. Okay, so I shouldn't get any answer less than 60 miles. It should be more than 60 miles, whatever that answer is. I don't know off the top of my head, but what I do know is that I know that it has to be more than a 60 miles at the end of the day. All right, so let's take a minute or two and give that one a try, and let's see what you get for that one. Okay, you got 84 miles. All right. All right. You guys are picking this up pretty fast, so that's good. Okay. All right. So 84 miles there. Good. All right. Doing good. Doing good. Okay. So let's take a good look here, and let's see if we can confirm that 84 miles is our winner chicken dinner. So again, we have 140% here. So again, we have 140 on the top here, over 100. Again, our 60 miles here is going to be our whole. So we get x over 60. So if we cross multiply here, we have 60 times 140 equals 100 times x. Uh, 0.2 kilometers for question D. Oh, I haven't done that one yet. But if you did, let me see. Would that be right? 10% is that. 1% is 0.5. 0.05. 0.2. Yep. 0.2 is correct for that. Totally agree with that. If you haven't asked question D there, Jacob, yep. 0.2 is correct. All right. Here in this case, we're going to divide by 100 on both sides. And so indeed here, x is equal to 84. That is correct. Good. All right. Any questions so far about that? All right. Good. Nice. Nice. All right. Okay. All right. Next, we're going to go ahead and do some word problems here. And hopefully this first word problem that we're going to be doing here will set us up for the other word problems in some respect. All right, because again, when it comes to more of these word problems, it's going to be the similar interpretation like we did in the previous example. All right, they talk about six steps here, six problem solving steps. But in reality, basically, we just want to look at the key here to this problem here. The key here, once again, is to identify the part, the whole, and percentage. Okay, to put in the proportion. Okay, so that's all we want to do here. Once again, it's just to do the same thing that we talked about here at the very beginning of class. Hey, let's identify the part, whole, and percentage and plop it in where it needs to go. Now let's go ahead and read this off here very carefully. And it says, Raley's Markets has 850 employees. Of these employees, 28% are students. How many of the employees are students? Okay. So in this case here, we have 28%. So we know where that has to go. I know you already did it, but I got to still set it up regardless. So got to do the process. Remember, I'll tell you it this way, Jacob. Sometimes getting to the right answer is great, but again, consistency is what's more important. 100%. So if I show the same process, and I know for some people it's super easy, and I'm not going to lie, it's super easy for some people once you get the pattern down. But again, consistency is what's the most important thing at the end of the day when it comes to mathematics. So that's the one thing I learned very carefully is that what can work for one problem doesn't necessarily always work for every problem. So you have to be really careful about, going through the process over and over again. Math can be a harsh mistress, I could tell you that. All right. So Raley's Markets has 850 employees here. Now, we just have to identify 850 here. So really quick here, 850 here, would that be the whole or would that be the part? Would that be the whole or would that be the part? The whole, that's correct. So again, if it helps, and we're just going to put 850 down here straight up. There we are. And then x is going to go up here. Now we just repeat the same process as before. So here we're going to get 850 times 28. All right, and so if you do 850 times 28 here, you're going to get 23,800. And then all you have to do is divide by 100 on both sides. And taking that balance. And so correctly stated here, 238 is going to be your final answer here at the end of the day. Okay, any questions about that? No? Okay. All right, good. Gonna kind of skip ahead here. All right. Now, let's take a good look here at this next question. So this next question here, let's take a look here carefully. Now again, wording means everything in these problems, all right? And that's how we're going to identify where things need to go. So again, it says 8 smartphones is 4% of what number of smartphones? So 8%, or 8 smartphones, sorry, is 4% of what number of smartphones? Okay. So let's take a good look here. We have the easy part here of 4%. That part isn't too hard. So the right side here is 4 over 100 like we normally have. Let's take a good look here at 8. What does 8 represent? Does 8 represent the part or the whole? Does 8 represent the part or the whole? 8 represents the whole. We have the whole here. So you're saying that we're taking 8 smartphones and finding 4% of those 8 smartphones. I could tell you 4% of 8 smartphones is going to be a decimal of some kind. Pretty not so nice one. But correct. We're trying to find 4% of the whole here. Now, I think, and I agree with you there. It can be difficult to determine which way you have to go, and how do you know that this is the part, and how do you know this is the whole? All right, let's talk about that here a little bit more carefully. Now, regardless of what these numbers are, I want to actually clue in on a couple of things. First of all, a few things, actually 3 things here. First of all, we have what number of smartphones, specifically what number. All right, what number here means just X. We don't know exactly, again, what number here means X, but specifically this means the whole part here in this case. That's what we're missing, is we're missing the whole part here. Of means, we talked about of here back in the beginning of this chapter here. Of means, if you remember here, of means to multiply. Okay, so it means to multiply. Is means, as we recall here, is means equals. Okay, so is means equals. So one of the other things that we're going to see in the next section, but is also important in this section here, is how we can view problems like this in order to make both of those methods work. Well, we looked at it from a proportional point of view. It's not so hard to figure out now that we have the we can put the pieces in place. But here's another way to think about it here. if we take a percentage of something, okay, essentially we take a percentage of something, that's going to equal the part at the end of the day. So what it means is that the part here is equal to the percentage, all right, times the whole. And so as we know here, as we've talked about here, equals means the word is in math language. And times here means the word of in math language. Again, mundane words, but has very important meaning here at the end of the day. And this is going to prove to be very helpful for us to know what numbers need to go into which parts so we can go ahead and solve for x at the end of the day. Okay, so that's why we can see here, we can see, okay, well, 8 is just the part, and the whole here has to be x. And now we just go ahead and proceed here. So here we get 4x equals 8 times 100. We get 8 times 100 here, 800. And what do we do next to solve for x? Divide both sides by 4. Good. So we divide both sides by 4 here. Then x is equal to 200. So 200 smartphones is going to be our final answer for that. Okay, any questions about that? All right, let's have you guys try a problem now. Let's have you guys try number 3. So try number 3 here in this case. All right, so let's take a minute or two and try number 3, and let's see what we get. Again, once you have an answer there, go ahead and post it in the chat. 1075, okay. All right. Any other answers? I have 1075 here, so 139.9, 139.32. Get 1075 there. Jacob, I think you did it backwards. I think that's the issue here. Remember that the part here was 387. Not the other way around. The whole is not 387. So be very careful about that. Your answer here in this case should be larger than 387 because of the way we set up this question. Any other answers? That's nice. Okay, let's take a good look here at this part. See if we get 1075. Here we get 36%. So 36 over 100. Now again here, 387, we identify this as the part. Okay, not the whole, but the part here. Because it says 387 customers is. Remember, is equals of being times. So if we go back to our little template here, again, part equals percentage times the whole. So what number is going to be our whole here in this case? Okay, and part here is going to be what it's equal to. So here, this is where we have 387 over x. Go ahead and cross multiply here. So we have 36x equals 387 times 100. So we get 36x equals 38,700 divided by 36. All right, and so if we just, again, you could do that straight up on the calculator. That's not a problem. And so here we have 1,075 as our final result. And that is the correct answer. Nice. All right, very good. Nice job. Questions about that one? Okay. Now there are variations of this problem here. Again, this is basically just like a straight up, hey, here's a single line kind of problem here. Now, if you had if you had an advanced word problem like this problem that you see up here on the screen, if you see a much more advanced word problem here, let's go ahead and discuss that here. And I'll show you exactly why this is actually easier than it looks. Despite having a lot of words in it, it's really not as bad as it may seem. It says at Newark Salt Works, 78 employees are absent because of illness. If this is 5% of the total number of employees, how many employees does the company have? All right, so in this case, my contention is that this problem here is the same problem that we had in the last example. Because the only thing that you have to really worry about here is the word if this. You're saying if this is, again, is being equals 5% of the total number of employees. And he says, well, what's if this? If this just means 78 employees. So 78 employees are absent because they're ill. So we could just like cross out the if this part and just replace that with the number 78. And we say, okay, 78 is 5% of the total number of employees. And then we can make a determination on how this works, which is pretty easy right after you do that, because it's first of all the percent over 100. And you know that 78 is just a part. So we have 78 over x. So you can see here, like, oh, just replacing two words and replacing with a number, that's all you're doing? And I'd be like, yeah, that's in a sense all I'm really doing. I'm not doing anything super crazy or grandiose. It's just exactly what you see there on the screen. So we have 5x equals 7,800. I needed that part. We'll divide by 5 on both sides. And now we'll get an answer for x here. So here we get 1,560. Okay, so that's our answer to that problem there. All right, good. All right. All right, so that's how we could do those problems right there. Again, it's just another way of looking at this problem here, just making a simple replacement and doing it the same way we did the last example. Really, in all honesty, not that hard to begin with. Okay, alrighty. Now, let's take a good look here at these problems here. So let's look at letter A here. Talk about how we can interpret this problem here. So the first thing that we have to do here in the problem like this is take a look at what we're trying to find here. We're trying to find, it says what percent. So what we have here is on the right hand side is we have x, which is the percentage, over 100. So that's a given here based on the wording of this problem. Now what we need to do is, of course, to determine what 13 and 52 represent. So let's look at the first number here. What does 13 represent in our proportion? Does it represent the part or does it represent the whole? Okay, that's right. 13 represents the part. So as we go back to our, let me scroll up here for just a moment, a little bit. So as remember, I'm using this idea that the part here is equal to the percentage times the whole. So let me do this again. Back. Do those next. So again here, 13 is going to be the part here. And then of course by default here, if 13 is the parts, then of course 52 has to be the whole. And so put 52 like so. And we're just going to go ahead cross multiply. And we're going to solve for x, same way. So 52x equals 13 times 100. So here we get 52x equals 1300. So divide by 52. Okay, and what do we get for x here? What is x equal to? What is x equal to? What's 1300 divided by 52? All right, 25. Good. So 25% is going to be our final answer for this. Good. All right, good stuff. All right, so by and large, it's not too hard. Again, now that we know how to set up the problem here, then it's like, okay, that's pretty straightforward. Okay, easy peasy, lemon squeezy. Yeah, nice. That's correct, Robert. All right. Okay, now let's take a good look here at not these problems. Which problem do I want to do? Actually, maybe I'll have you try one of these problems. Actually, let's have you guys try number 3 here. What percent of 2,280 court trials is 1,026 trials? Let's take a minute, and once you have an answer there, go ahead and post that in the chat. So nice, quick, short problem here. Got 45% there. Okay. All right, 45%. All right. Now let's take a good look here. See if that's what we get. So we don't know the percentage here, so it has to be x over 100. It says what percent of 2280, so that means that 2280 here has to be our whole, is means equals 1026 being our part. So here we're going to get our part 1026 over the whole, which is 2280. So what we're going to get here specifically, we'll cross multiply here. So cross multiplication is going to net us what here? So we're going to get 2280x equals 1026 times 100. Okay. And now we're just going to go ahead and take 2280x equals 102,600. And we'll divide by 2280 on both sides. Again, just keeping the balance. And so if we do that out here, again, you can use the calculator for that part. They are pretty big numbers. And so indeed, we get 45%. Good. That's correct. All right. FM stream, Geza? Yeah, the FM stream will be on Saturday. So for my part 2 FM stream, that'll be Saturday, my friend. I'm still in session 0, so. But yeah, part 2 on Saturday. All right. All right, we're going to take a look at a few more examples here. That's right, don't forget the hashtag, bro. All right. All right. Let's look at letter B. Let's look at letter B here. Now, what is important here is let's read this off here for letter B. All right, so letter B says rainfall this year was 33 inches, while normal rainfall is only 30 inches. Yeah, you can use a calculator for these. Absolutely. You just have to be able to set it up properly, that's all. You can't use a calculator if you don't know what you're entering in. You know what I'm saying? All right. So rainfall this year was 33 inches, while normal rainfall is only 30 inches. Okay. Oh, right on. Send me the link to your channel there if you want me to just send you a follow. What percent of normal rainfall is this year's rainfall? Okay, let's read this. Let's read this off carefully here. What's the square root of my nose? Wow. I don't know what route I need to take, but it's kind of a long drive across my nose. I could tell you that much. And like, kind of going like this, square route, man. Square route. Maybe I should put a map on my nose about how big it is. Well, genetics. Yeah. Oh, man. Oh, man. I'll have to put that a little bit later, guys. I need to finish these problems up. Then I'll put up the anthem for you, okay? I promise. All right. So let's talk about what we can see here. The first thing that we can see here is what percent. Of course, that's going to be our x value here. Now the real question is, so that part there in terms of our formula, or in terms of how we're going to set up this problem here, um, is going to be 100. Now, here's the important part here, okay? Here's the important part here. What is 33? Is 33 going to be our part, or is 33 going to be our whole? Is 33 going to be our part, or is 33 going to be our whole? Okay, that is correct. 33 here is actually going to be our part here as part of the proportion. Let's talk about that here for just a second. Then by default here, 30 is going to be our whole. Now here's the one thing that you have to take to the bank. We have what percent of as we know is times, normal rainfall. So the normal rainfall amount here is going to be our whole, right? Because when we talk about it, right, our key is that again, part is equal to the percent times the whole. So is means equals this year's rainfall, and then of course this is going to be our part right here. So I want to actually put a very important note for this here, because this is our part here is 33 and our whole here is 30. And this is kind of what I want to stress on here in this problem. So note here. It is not true that the smaller number is the part and the larger number is the whole. This is not true, okay? You have to read and interpret the problem here carefully in order to put that together, okay? Again, remember to use here, again, very important here, again, important, use, again, part equaling percent times the whole, okay? So again, remember, this is strictly because we can get percentages that are above 100%. All right, and because that's entirely plausible here, that is why I put this note here in place, where it's not going to necessarily be 10%, and it's not necessarily going to be 90.9. Again, this is part of the process here. So if we do this out, we cross multiply here. Then here we're going to get 30x equals 33 times 100. So I can tell you I really love the answer of 10%. So for various reasons. So 30x here is equal to 3,300. Then you can divide by 30 here. And if you divide by 30 here, your actual percentage is 110%. That's going to be the answer here to this problem, is 110%. One of the things about mathematics, if you ever want to know, is one of the so So hopefully that my stream is deciding to not be poopers. Okay. Less poops, please. Stream buddy. Alright. Anyway, one of the things that's important for math is I always go with this idea here. Alright? So this idea here for math is actually rather important. Never assume in mathematics. Alright? Just because you think one thing goes one way doesn't mean it always works for every single way in every single type of problem, unless it's proven otherwise. So that's why the process here is more important than, it's like, oh, I got it this way, so it's always going to work that way. Well, no, there could be exceptions to the rules, as math tends to have. So if never make the assumption, just go ahead and do it. Gaza, thanks for the follow, by the way, buddy. Um, but yeah, never assume. That's one of the most important things to kind of know, is to be very careful about, is that part there. That tends to get you in a lot of trouble. If you make an assumption and then it doesn't work out that way, you're like, well, what happened? Well, yeah, you just thought it was going to happen that way, and the numbers told you otherwise. So, got to be careful about that. That's for sure. All right. So 110% is what we get here in this case. Okay. Now, the next one I would like you to do here, actually last problem here that I would like you to try, is go ahead and try number 4 here. So let's take a couple minutes here with number 4, all right? And I want you to go ahead and give it a go, all right? And once you have an answer here, go ahead and post that in the chat, okay? So the service department set a goal of 360 service calls this week. If they made 432 service calls, find the percent of their goal that they reached. Got 120, okay. So Ruchi got 120. All right, any other answers? 120%, okay. Got the same answer there, good. Anyone else? All right, 120. All right. 120. All right. Okay. So let's see if the answer is 120 here. Well, that looks pretty good to me. So, but let's go ahead and see if we can confirm that to be true. First of all, we're trying to find the percent here. So we're going to have x over 100, just as usual. Okay. And then next, we have to identify the part. All right, so we have to find the part and the whole here. So they set a goal. So they said find the percent of their goal. So of their goal here is going to be their whole here. So that means that 360 here is going to be your whole here. And 432 will be your part. So here we have 432 on top and 360 here on the bottom. Okay, so here we get 360x equals 432 times 100. So here we get 43,200. We're going to divide by 360. And if you indeed divide this by 360 here, our final answer here is indeed 120%. That is correct. Nice job, everybody. Spot on. All right. Very nice. Any questions, anybody? Okay. Now, that's the end of what we want to be talking about here today. That's the end of section 6.4. Next time here, we're gonna hopefully finish up. My goal is to finish the last two sections of chapter 6. Once we're done with the last two sections of chapter 6 on Tuesday, we're going to talk about the test here regarding chapter 6, and then right after chapter 6, after we come back from the break, uh, uh, then we're going to talk about the last chapter here, which is chapter 9. Okay, so chapter 9 is the last chapter there. But my goal on Tuesday is to finish the last two sections here. We've pretty much done most of this next section, even though we haven't talked about it. We're going to talk about how to do it in decimal, so that first method there. And then 6.6 is just more applications, so I should be able to pass that without too much trouble. Excuse me. There's a lot of applications in this section here. So, all right. So it shouldn't be too hard. But again, that's the goal here for next class, to get through chapter 6, talk about the test, and then we'll get into chapter 9 after Thanksgiving break. All right. In the meantime, though, everybody, everyone have yourself a very wonderful afternoon. All right. I thank you all again for coming out to the stream. Have yourself a very wonderful afternoon. All right. Please take care of yourself. Remember to stay safe, stay happy, and stay sane. Okay. Hopefully we're seeing the end of the rainbow to this final COVID stuff here. So hopefully, cross my fingers next week. Hopefully we get that emergency approval from the FDA. That'll be good. All right. In the meantime, yes, great job everybody here today. Take care of yourself. All right. And I'm gonna go ahead and put in a small raid here. I'll just put my raid over to hashtag United. They're probably playing Among Us or something. Okay. So everyone, uh, everyone here, we will see you later. Have yourself a wonderful weekend, everybody. Take care of yourselves. Have a great one. All right. You know where to find me. All right. Take care.